All right, let's dive right into this explainer. Today, we're going to expose a massive hidden trap tucked away inside Cambridge IGCSE Physics command words. I'm talking about a trap that literally costs students critical marks year after year. Honestly, it is incredibly frustrating for anyone who has put in the late-night study hours. But the really good news? It's completely avoidable once you know exactly what the examiner is secretly looking for.
So you're probably wondering, what exactly is this trap? Well, when you flip open your exam paper, the very first word of a question sets the entire stage. Misunderstanding whether a question is asking you to state, describe, or explain creates an instant, massive risk to your grade boundary. Think about it. You could write down a beautifully articulated paragraph of totally accurate physics facts, but if you don't actually answer the specific command word, you score an absolute 0. It's a huge confidence shock, and it can totally derail your entire exam if you aren't ready for it.
And this trap is especially devastating when we get into the rays and waves section of the syllabus. When you hit topics like reflection in plane mirrors, the refraction of light, total internal reflection, and lenses, you are basically stepping into an academic minefield. This entire block of the curriculum is notorious for triggering those command word traps and sneaky calculation errors. Why? Mostly because it blends really abstract theoretical concepts with heavy, multi-step mathematics.
Because of these highly specific traps, your ordinary, everyday revision tactics just kind of fall apart under actual exam conditions. You can memorize the textbook cover to cover all day long, but when that clock is ticking, the pressure causes students to literally bleed marks. We see the same painful yet totally preventable mistakes over and over. Forgetting basic units, rounding numbers way too early in a calculation, giving vague, non-scientific explanations, completely messing up graph axis scales, or even just plugging the wrong variables into an equation. Doing all the hard work of studying only to lose the mark on a simple technicality? Yeah, that's a scenario we want to eliminate entirely.
This brings us to an absolutely crucial shift you have to make in your strategy. Rote memorization, just dumping every single fact you know onto the page and hoping the examiner magically finds the right answer, is not going to cut it. You have to remember, these examiners are grading hundreds of papers. They are scanning for very specific triggers. You must adopt what we call mark scheme thinking. This means knowing precisely what the grading key requires and serving them exactly that. Nothing more, nothing less. It's not just about knowing your physics, it's really about outsmarting the structure of the exam itself.
To execute this mark scheme thinking perfectly, our source material outlines a highly effective 4-step answer framework. It goes like this. Step 1. State the core physics concept clearly and concisely. Step 2. Provide the evidence or data directly from the question prompt. Step 3. Apply your scientific reasoning to logically connect that concept to the data. And finally, Step 4. Lock it all in with strict examiner wording. If you follow this blueprint religiously, you are virtually guaranteed to capture the highest possible marks in your optics answers.
Now, in just a moment, I'm going to reveal a specific examiner clue that completely changes how you should approach an answer. But before we get to that massive clue, we need to put this new 4-step framework to the test in a real-world scenario. You really need to see exactly how this framework takes all the guesswork out of the exam and makes the correct answer entirely obvious.
So, let's apply step 1 of our framework to a classic Cambridge-style example, total internal reflection. If an exam asks you to define this, you can't just casually write, "the light bounces back." No way. You need strict physics terminology. Total internal reflection is the complete reflection of a light ray back into its original medium when the angle of incidence exceeds the critical angle. Notice the absolute precision in that phrasing? Every single word earns its place on the page, leaving absolutely zero room for examiner ambiguity. Okay, I want you to pause for a quick second and test yourself. Predict how a strict examiner would grade this specific, real-world student answer. The light reflects because the angle is big. Based on the 4-step framework we just went over, what is the massive, mark-losing error in that sentence? What are they fundamentally missing when they try to explain this phenomenon? The difference is actually striking when you lay them out side by side. That flawed answer? It loses marks instantly because the word big isn't a physics term. It's entirely subjective, and it completely fails step 4 of our framework, using examiner wording. On the flip side, the top band answer secures all the available marks by executing steps 3 and 4 flawlessly. It cites the correct scientific reasoning and exact terminology by stating the angle of incidence is greater than the critical angle. That is exactly how you lock in the mark and protect your grade boundary. All right, so we've successfully tackled the written explanations, but let's raise the stakes a bit. Where do most students drop marks when the heavy math comes out in harder calculations, like with refraction and lenses? You might have Snell's law memorized perfectly. You might even set up the algebraic equation exactly right.
But there's a hidden trap waiting for you right at the finish line of your execution. It all comes down to extreme mathematical precision, formatting an answer to exactly 2 decimal places, for example. The final answer isn't just whatever arbitrary long string of digits you punch out of your calculator. Failing to track your significant figures or rounding way too early in step 1 of a complex multi-part question will absolutely cost you those final method marks. The crucial takeaway here is that the examiner isn't just testing your physics knowledge, they are rigorously testing your mathematical discipline.
To protect yourself against these math traps, the source provides what I like to call an ultimate examiner-style checklist. Treat this as your bulletproof final check before you even think about turning the page. Ask yourself, have I clearly substituted my values with the correct units? Are my significant figures correct based on the data provided in the prompt? Is my final conclusion logically supported by the data I literally just calculated? And finally, did I use exam-safe wording? Skipping this quick mental check is exactly where A-grade students accidentally slip down to a B. Let's really cement this strategy right now so you never forget it. From this moment on, whenever you approach an optics question, always filter your knowledge through this 4-step sequence. First, state the concept. Second, extract the evidence and data. Third, apply your scientific reasoning. And fourth, use strict examiner wording. If you make this your default habit and practice it consistently, then intimidating Cambridge IGCSE Physics paper stops being a scary, unpredictable monster and just becomes a highly predictable puzzle. So you now have the ultimate foundational framework for tackling optics content. But there is a second, even more dangerous trap waiting for you. And it depends entirely on the exact question type you face on exam day. You see, knowing the physics is only half the battle. Knowing the specific strategy required when the command word abruptly shifts from describe to evaluate, that is the crucial other half of true exam mastery.
If you want a highly recommended resource for mastering these specific command word nuances, the source material actually points students directly to their YouTube channel. They suggest subscribing to Ace the Exams at the handle @acetheexams_IGCSE to find a ton of more detailed strategies and breakdowns for excelling in all your Cambridge examinations. To fully resolve this remaining gap in your strategy and to discover the safe shortcuts for all those different command words, the source material offers a follow-up guide that focuses exclusively on common traps by question type. But as we wrap up this explainer, I want to leave you with a provocative thought to chew on. Are you currently losing marks because you don't actually know the physics, or simply because you haven't yet learned how to speak the examiner's language? You have the optics framework now. The real key going forward is learning how to adapt it when the rules of the question suddenly change. Keep learning, keep practicing that mark scheme thinking, and I'll catch you in the next explainer.